All right. Hi, everyone. Welcome to 3X Point. This is the place where we train people on SQL Server, database administration, analysis, business intelligence, and depending on which area you would like to focus in database profession, we believe in hands-on. Most of our uh, deployment have been hands-on training, teaching people on different areas to databases, and we meet periodically like this every week to give hands-on training. Today we have a number of agenda to cover, and we will proceed shortly. Right. Now these are the areas in which we intend to cover today. We intend to look at select statements and the asterisk symbol. We intend to look at data manipulation language, DML. We've seen DDL before, and we were taking it a step further today. We intend to have a look at constraints. What are constraints? A lot of people already have been telling me they're having difficulty understanding what constraints are, and we will try to explain them in detail today and demonstrate to you areas in which you can use them, how to use them, how to enforce constraints, and you would appreciate its use by the time we're done teaching you this. And we'll look into identity. What is it? What does it mean? What is it used for? How do we use it? When to use it? And then we will have a look at the assignments you had to do during the week. We will treat it today and show you what the expectations were. Okay, and then we will treat a business use case today. The whole essence of this training is to show you things that you would expect by the time you eventually get a job, or by the time you eventually start working in the industry on production environments, how to deal with business requirements and how to use the things that you've learned and apply it to the real world. Okay, so let's get started. Now, talking about DML, we already know what DML is because we've been talking about this right from the day we started, which is 3 weeks now. And simply put, it is data manipulation language. It is the language within SQL that we use to manipulate data. Talking about inserting data into a table, talking about updating data, talking about deleting data. And okay, let me take it away. It looks like something is missing. Okay, so it's select, insert, update, delete. Okay, it's fine. This arrow should have been here. Okay. So we have select. Select is a DML. There's been quite a number of arguments around that. Some people don't think it's a DML, but it is a DML because you can use select to perform manipulation operations. And by the time you start using it more frequently, you will understand what areas you use select to perform DML operations. Insert, just the way it sounds, insert. Think about an Excel sheet, for example. You want to put a new data into it. You want to put a record into an existing Excel sheet. That's inserting data. And similarly, in SQL, we have the insert keyword that we use to perform DML operations. Similarly, update is a DML, and you use it to do manipulation as well. You have an existing data and you want to change it. For example, you have a column with names of people and you have a name called James. You want to change James into David. So that's an update operation. Delete, something that exists on the table already. You want to delete a record. You want to delete all the records from a table. All these are DML operations. They're simple things, but you just need to understand that they are DML, and we'll show you how to use them. Now, you would have noticed by now that when I put merge, like when you see something like this that's not part of the arrow, you know it's part of DML, but it's just that there's a little bit of more information you need to know about it. Now, the reason you've seen it like this is because it is not common. When we talk about DML, the first things that come to you is insert, delete, and update. Merge is the same thing as insert and update. That's why they call it upsert. If you look up here, you see upsert operations, and upsert means update and insert. So think about merge as two tables, one on the left and the other on the right, containing the same data. Now, what you're trying to do is you want to merge them and find out if there's an existing record. If there's an existing record, you want to update the record. If the record does not exist, then you want to insert into that table. So the one on the left has some data. The one on the right has some data as well. Both of them have similar data, right? But the one on the left has some data that is not on the right. So when you perform a merge operation, you are saying, I want you to either update or insert. When you find a matching data, the same identity column, the same ID column, the same name, the same details, everything, okay, but probably the name has changed from James to David. When that operation is found, then update. If it finds that there is no matching ID from the two tables, then perform an insert. So you probably not understand these things until we do a demonstration on it. And we will, I promise you, we will do a demonstration on merge as time goes by. But at this stage, you should understand that we have merge, we have update, we have insert, we have select, and we have delete. Okay, what are constraints? Now, remember before we talked about the fact that your database needs to have integrity. You don't want to have a database that has no integrity. You don't want, you know what, when I said if someone walks up to you and tell you I don't have integrity, what would you think of that person? If you were considering doing business with that person before and the person looks up to you and says, hey, I don't have integrity, you want to walk away, right? Similarly, you don't want to keep a database that has no integrity. The reason is simple. You won't rely on it. If it doesn't have integrity, you can't rely on it. Then why do you want to keep it? Okay, so to be able to have a database that you can rely on, then you need certain things that can help you to achieve that. And those things are what we call constraints. And we have different ones. Before we go into the types of constraints, let's have a look at the things that we've highlighted here. Number one says, these are the rules enforced on data columns on table, or they are used to enforce business rules. So say, for example, we're running a school business. We have year 1, year 2, year 3, year 4, year 5. We know that people in year 1 are between the ages of 5 and 7. People in year 2 are between the ages of 7 and 9, like that, up till we get to year 5. That's the business rule. And you have a database that keeps the data of all your students, the student records. if you don't enforce some kind of rules on your database, somebody can just mistakenly put the name of somebody who is in primary 5 or year 5 and put that name in year 1. If that happens, your database becomes inconsistent. It begins to lack integrity. And then you can put some rules that would say people in year 1 should be between the age range of 5 and 7. That's the business rule, and you can enforce it such that if somebody tries to insert a record that does not meet that rule, it will throw an error and it won't accept that data. So you can go to sleep and be happy that your database will keep on running. You are 100% sure that if anybody tries to put a kind of data that you don't want them to put there, the database will reject it. And that's what we're talking about here. Okay, so there are rules. Number 2 says they are used to limit the type of data that can go into a table. We're still talking about the same thing. It's just that we're looking at it from different angles. So if we say it limits the type of data that can go into a table, we're still saying we enforce some kind of rules that enables it to do this. Number 3 says they are used to assure us of the integrity of our data. Same thing we're still talking about. Number 4 says they ensure the accuracy and reliability of the data in the database. So all these things are still the same thing that I've been saying. It's just that you need to understand all the different angles to which constraints are used. And what are the types of constraints? We have default, we have null, we have not null, we have check, we have primary key, we have foreign key. You have been working with some of them already, but I would like to explain to you in clear terms what they are used for, and then by the time we go into our lab, you will see them in operation. Default. What we mean by default? Default simply is to say if I don't specify a value to put into my database, then specify a value yourself. I mean, the database engine will put in the value itself. And the value that the database engine will put itself is something that you already have specified before. So you can say, for example, we sell certain products in our company, and we have several regions in which we sell this product. We have Central, we have Northwest, we have Southwest. Now, in the database table, if somebody buys a product and the database engine tries to put a data in there to say this product was bought at a specific region. Now you can enforce a rule because you don't want that region column to stay empty. And you know for sure that in Northwest, the products that are sold in Northwest and products that are sold in Southwest are also sold in Central. Meaning if you go to Central, you will find the products there. So you can enforce a rule and say if Northwest or Southwest is not specified by default, please put in Central. So this is what we're saying here. So it depends on the business environment. Different businesses have different requirements and different things that they want, or different way they want their database to operate. But the bottom line idea is for you to understand how default works. Now, moving on to null. Null simply means I don't know. Null is not a figure. It's not 0. So, for example, if on a column I am able to say to insert null into a column on a table, what that simply means is at the time this data is going into the database, I don't know the value. I might know later, but for now, I don't know what the value is. So I can put null into it. So you can make the database to accept null values. Meaning if you're trying to insert data into the database and at the time you're inserting the data, you don't know the value, you can specify null. Or if you don't specify anything at all, the database itself automatically can insert null for you to say the user has not specified any value for this thing. So for now, I'm just going to put null so that by the time they know what the value is, they can come back and update the database. Update going back to DML. Okay, so we can update the database and put null in there. In contrast, we have not null. Not null is something that confuses a lot of people, and it's just the opposite of null. So it's saying on this table, I don't want you to specify null. You must specify a value. Okay, so it's just like you have a table that has a primary key. We understand what primary key is at this point. We've been working with this for some time. We know that a primary key is something that uniquely identifies records on the table. And what that means is you cannot put null on a column that has primary key because the database relies on this column to uniquely identify something in the database. So meaning, hey, on this column, do not put null values there. It must have a value. That's what not null means. Anywhere you see not null, don't be confused. It simply means on this column, it's going to have a value no matter what. Okay, there's something I just remembered. I'm going to put it in there, but before then, I'm going to talk about everything. There's still one other constraint that's not in here at this point. Then we have check. Check is a constraint that is similar to what I said earlier on about the school having year 1, 2, 3, 4, 5, and 6. To say in year 1, I don't want age range that is other than 5 or 7. So you can put a check constraint to enforce that rule. I say on this column, I only want people with the age range 5 and 7. If someone tries to put age 20 there, it will reject it. So that is check constraint at work. Primary key and foreign key, we already know that. We just touch it briefly. Primary key uniquely identifies columns on the table, and foreign key, simply put, is a representation of the primary key on another table. So if you have a table that has a primary key, if you find that same column on another table, it becomes a foreign key on that other table, and then it establishes what we call relationship between those two tables. Okay, let me put one more here because there is still one other constraint I would like us to talk about. Okay, one moment. And that's unique constraint. Okay. For unique, it's similar to primary key. So don't get confused there. Uniquely identifies columns on a table, just like primary key. However, there is one major difference between both of them. And that difference is that with primary key, it does not allow any null value. I repeat, primary key does not allow any null value on the table. But unique can accept one null value, not more than one. One null value can be accepted by unique. So if you specify unique on a table, a unique column on a table, it will allow you to have just one null value on that table, on that column. But primary key does not allow null on the column. That is number one. That's number one difference. The other difference is that on a table, you can only have one primary key. If you have, let's say, 10 columns, those 10 columns can only have one primary key specified on that table. But with unique, you can have more than one unique specified on the table. So you can have 5 different columns having unique constraints on them. So having a unique constraint is like an extension of the primary key. So because we can only have one primary key on the table, and we need more columns to have uniqueness on that table, then we can specify unique on the other columns that cannot have primary key just because we already have a primary key on the table. I hope that that's quite clear. So we understand the differences, and this is a very, very important interview question. Sometimes an interview question can go like this. If I have a table and I want to test, I don't know what sort of constraint is on that table, but I want to test, I want to know if it is unique or primary key without having to go into the database metadata or querying the system tables to know what the structure of the table is. How will I know if it's a unique or primary key? That's an interview question, and I've used it to interview a number of people before, and I've been surprised how people do not know these simple things. Okay, and it's very important that you know them as a database architect, as an analyst. You should be able to identify the differences, and the answer is just simple. It is try to insert null value into the column. If you accept unique, then if it accepts null, then you would know that it's a unique constraint that's on that table. If it does not accept null, the error message will tell you that it has a primary key constraint on it, and you found your answer. If null is already on the table, because unique accepts null, if it was unique key that's on the table and you try to put null into it and it doesn't accept it just because a null value already exists, the error message will still tell you why it didn't accept the null value. So you can easily tell if it's a unique or a primary key on it. There is much more to unique and primary keys. By the time we start talking about indexes, we'll come back to this topic again, and then you will see some more detail about what makes them different from each other. But for now, this is good enough for us to proceed. Now we need to go into our assignment. Okay. So we had an assignment during the week, and a lot of us tried to attempt the question. We tried to implement the solution. Some got it right. Some are still struggling with it, but we're going to resolve the mystery right here today. And we will treat this, and then we will treat something else that will move us into understanding some of the topics that we've discussed so far and introduce us to some more new topics. Right. Now, to make it fast for us, I've already prepared the statements. So we will just go through them. So I'm not going to start typing them one by one so we can save some time and be able to move quickly and into other things. All right. So we have a general requirement. This general requirement means it applies to all the tables that we intend to create. The first requirement is use SQL syntax to create the following tables. You can easily create the tables by right-clicking this and creating the tables. You all know how to use the GUI to do that, but we want you to know how to use SQL syntax because it is very important for you. The second requirement says all primary key column must increment automatically. Now there's a test here. There's a reason why this was written this way, and we wanted to see how you are able to implement that. The third one says all modified date column must have a default value of current time. We haven't started talking about functions, but this assignment is not only to make you do things that we have taught you so far, it is also to push you to do some more research on your own and discover things. So it's asking us to introduce something here today, which is functions, and we will get to that in a minute. All right, creating the first table. Let me push this down so we can have a look at this only. This is our create statement for the table. So we have the first column, person ID. We have the data type, as you already know, and we have primary key. Now let me tell you this. The next thing we're going to do after today's session is I'm going to send you some materials which talks about database normalization and some other things. And with database normalization, the first normal form says that every table must be identified by a unique column, meaning best practices says every table must have an ID column. That's just simply what it's saying. A column that can hold values to uniquely identify every record on a table. So what that simply means is for every table that you're going to be creating, it must have an ID column, something to tell it that this is the ID for this table. And that ID column must be the primary key, because that's how you can guarantee uniqueness on the table with the primary key. Okay. Now it says again, number 2 says all primary key column must increment automatically. That is what identity is doing here. What identity does is it helps us to increment automatically, meaning if I insert the first column on the table, the first record rather on the table, and the ID is 1, by the time I insert the second record, I don't need to specify 2. Automatically, it will specify 2 for me, and it will keep on incrementing like that. And that's because I've only said identity, but internally, something like this is written in front of it. And what this means is simple. It means start with 1, increment by 1. This is the default. If I don't specify this, this is what's going to happen. But if I don't want this default to take over, I can write something else. I can say 100 and increment by 1. I can even say 100, increment by 100. So what that means, it will be 100, 200, 300, 400. I can say 100, increment by 10. Okay, I can say 10, increment by 1. So it will be 10, 11, 12, 13, you know. So that's just it. But the default is 1, 1. And that's what the first one is saying. Say person ID, data type, integer, primary key, identity, increment 1, 1. So first requirement is sorted out with this. The second requirement is sorted out with that. Moving on, we have our title, Virtual 5. We already know all this one, so I won't go into detail of all that. And then we have our email column. Now let's see, do we have, okay, yeah, so there's a requirement here that says email unique. So what this is saying is specify a unique constraint on this. And it makes sense. Every email address should be unique. Because we already have primary key here, we can't say primary key here again. Do we know why? Now this is the time I want you to start answering me questions. Do we know why? Start typing your answers. I want to know why we cannot specify another primary key here on email. Okay, I'm waiting for your answers, but I'm not going to wait. Let's keep on, but I need you to type in your answers. And I want everybody to type in answers for that because we've already talked about this. All right. Okay, Gbemisola has said something. Femi has said something as well. Okay, you guys actually want me to wait. I couldn't even continue with what I was intended to say. All right. So Candy said because there must be one primary key for each table. That's correct. Femi said because we can't have two primary key on the table. That's correct. Gbemisola said maybe we can't have two primary key. You're absolutely right. Good. So that means you've been following me. So we have just, so we can have just one unique here. Okay. So again, we have created dates and we have modified date. Now this is another requirement that says all modified date column must have a default value of current time. Now we haven't introduced this. This is a function. Anything that you see that has open brackets and close brackets like that is a function. We're still going to go into functions in detail. But for now, just know that anything you see with open and close bracket like that is a function. And there's a function that helps us to retrieve the current date and time. So if you want something to give you the current date and time, it's not going to bring the date and time from the cloud or from heaven or anywhere. It's simply just going to go into the server that the database engine is and pick the date and time setting on there. So if the date and time setting is using American time, by the time it inserts the date and time, it's not going to use UK time. It will use the date and time setting of the server that the database engine is running on. So you need to understand that too. So that's where it's going to get its date and time from. So, but there is a constraint here as well. This is a constraint, default. And what this means is what I said earlier on before, that default meaning by the time we want to insert into this table, if we do not specify the date or time, please get us the current value. From where? From the server, and just put it there. And what this is helping us to do is, if we want to track every changes that happens on our database, we want to track it, we want to know when a data was modified, then we want to do this. Obviously, if someone is modifying the data, they probably won't even bother to put the date and time that they modified the data. But this will help us to keep the auditing in check. So by default, get dates will go into the column and we're fine. It depends on the business requirement. A requirement could also say, okay, put a column created by and modified by. We want to know who created the table. We want to know who modified the table. But this particular requirement is not asking us to do that, but I just chipped that in. So if you did your assignment like this, you're good to go. Now, there is no right or wrong answer to things like this. As long as you meet your requirement, every other thing else doesn't really matter. And what I mean by that is this. If, for example, you said title voucher 50. Now, it doesn't mean you're wrong. It will just sell you out if you are how professional you are or how much of experience you have. Because if you're going to put title on this table, we all know that title can never ever be more than 10. I mean, what sort of title will have 10 characters? It's either Mr., Miss, Doctor, just name it, Master. It could be anything, any of these things, but it can never be 50. So if you create this table, of course it's going to create. It won't throw you an error. But these are the things that make you different from somebody who is not experienced. Somebody who's not experienced will not care, will just say, as long as this will create, it's fine. But hey, don't forget that all these numbers actually matter in the sense that you're using up this disk space, because all this data is being stored somewhere. And where is it being stored? It's stored on the disk. This is the disk. Usually you have more than, the C drive. This is the C drive here. But you can have D, you can have E, you can have F, or any other, kind of partitions. And look at this one. We have 11 gig free of 39 gig. By the time you insert data, these numbers will keep increasing. You've used 11 gig. By the time you keep on inserting data, you'll be increasing to 11, 12, 13, 14, and probably use up the whole 39 gig left on the disk. And there's an implication of the size that virtual takes. So the size of the disk that virtual 5 will take is different from what virtual 50 will take. So these are the things you need to watch out for. But ultimately, we fulfilled our business requirement here and we can proceed. Now the second table says address. All right. Now we have our requirement still that says all primary key must increment automatically. So we must have our primary key column incremented automatically and modified date. So similarly to what we created before, we should be fine with this. All right, so that's our address table here. So we have our address, we have our data type, we have our identity, we have primary key. Now something you should observe again is this. Here, identity came last. Here, identity came after data type. It doesn't really matter where you put it. As long as your data type follows the column name, other constraints or other things that you specify after the order doesn't really matter. What matters is once you finish specifying your constraints, just put a comma there to show that I'm done with this column. I'm moving on to the next column. All right, so that's that. So we have address line 1, address line 2, we have city, we have state, we have postal code, created date, modified date, and modified date get date function. Remember our requirement, and it has to be default. Okay, because that's the requirement that says all modified dates must have default. Okay, so we're done with this. Let's move on to the next one. Create table, person address, person ID, integer, identity, foreign key, references person. We did this last week, so we shouldn't have problem understanding this. What we're simply saying is person ID should be referencing person. But hey, something is missing here. We don't have our identity column. I mean our uniqueness column, a primary key column for this table. So we can call it address underscore, person underscore address, that's the identity 1 1. That doesn't really matter if you specify 1 1 or not. If you don't, it will still work. Primary key, and that's it. So that will create our table. Then we have what's the next one? Product. Okay, did we request for product table? Yes, we did. Okay, that's it right there. So product, we have integer, we have identity, we have primary key, we have name of the products, we have created date, we have modified date, default, get date, and that's it. Now this is the interesting part, because there's a requirement there that says, there's a special requirement there that says name field must have a check constraint that support only the specified regions. So we have a company that operates in all these regions, and we don't want data of regions that don't exist within our company. As you can see, we don't have Africa, we don't have Asia, you know. So all we have is Northwest, Northeast, Central, South. What Northwest, Northeast means, we don't care. The business has said what they understand, and they've said this is what they want. We're just going to put it in there for them because this is what the business says that we should do. In some cases, you might just be curious, say, oh, so what does Northwest mean? What does Northeast mean? You can ask questions, okay, and say, oh, but how would we know what Northwest of where? You know, you can ask questions, and there can be, possibly there's other ways of identifying these things from another table within the database. Okay, so all those ones are talks for another time. By the time we start building, you know, the using normalization, you know, creating different tables from an unnormalized table, you understand what I'm talking about. But for now, this is what the requirement is. Let's just do it. And it says it must have a check constraint. So how do we implement check constraints? This is the interesting thing here. All right. We already have our territory ID, integer, primary key, identity, we're fine. Now look at that, name. We have our data type, standard, yeah? Yes. Now, this is now our constraints check. Just the same way we'll mention default, or just the same way we'll mention, what's the other one? Primary key, you know, after data type. Just the same way we'll mention foreign key, or you know, default, or you know, all them other constraints. Similarly, we'll just say check, because that's the name of the constraint. We'll just say check. So what are we checking then? What are we checking to say if it is not this, nothing else? This is the syntax. You have to open the bracket and close the bracket. Within the open and closed bracket is all the things that you want to check and specify. And then you say name, meaning this column. Okay. Name should be equals to Northwest. That is the number one check. And then you say or name again equals to Northeast. And then or name equals to Central. All the things that the business said they want. So you just keep repeating the same thing. Or name equals to this, or name equals to that, or name equals to this. Once you're done, close the bracket. That's it. Now there are different things that you can do with this check. It could have been and, right? Everything here could have been and. It could be or. Now, can you tell me what the difference is? If I had said and for everything, I want everybody to be involved in this now. If I had said and, what do you think will happen if I try to insert data into this table? If I try to insert just Northwest, if I try to insert and say, okay, the sales territory for this column is Northwest, and there's a check constraint that says name equals to Northwest, and name equals to Northeast, and name equals to Central, and name equals to Southwest, what do you think will happen if I try to insert just Northwest? Tell me. Come on. Come on, everybody. Let's get to work. Okay. Bimsala said it will pick everything. Okay. Anybody else? Are you still thinking? Femi said it won't go as it will expect all the names as one. That's it. That's correct. Femi, you're right. It would expect everything to go in at once because you've said and. All right. So what all means is if it is not northwest, it could be northeast. It could be central. It could be any of all these things. That's what check constraint does for us. Now let me take this away and give you another example of check constraint. If I said territory ID greater than 5 and I said integer, what do you think, what sort of data do you think will go into this table with this check constraint? Everybody, I want your response. I'm waiting. I'm just waiting on the first person that gives me the answer, and that's it. I'm not going to wait on everyone. So if I try to insert, I mean, no, let me not tell you what I will try to insert, but just explain to me what sort of data do you think will go into this column? Okay, so Femi and Ahmed has already given us answers to say that territory ID value greater than 5 only will go into this. So that means if you try to insert number 6 into this column, if number 6 does not exist here, will it go? Yes or no? Okay, that's something I'm going to leave to you to go and test, because this thing is about, trying different things. Think about different business requirements, think about different things possible and test them. Try to insert values into it. Try to, see what the results will be. And yeah, so that's it. Let's move on. Okay. All right, and then the last one is customer demonstrate relationship with foreign key. So that's what this is saying. Say fields, customer ID. Okay, let's go into the created table. So customer table. So we have primary key for our customer ID, and we have identity incrementing, and then we have person ID, integer, foreign key, references, person ID, territory ID, blah, 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 blah. We understand all these things. Default, get date, and all this. All right, so proof of concept. Let's try to run this query and let's see if it will work. All right, so do we have a table called 3x point on this server? Yes, we do. Okay, I'm just gonna name it 3x.2. And let's run this. Because we don't have the database created already. Let's create it. New database. 3x.2. We have an error. It says multiple identity columns specified for table person address Where is it? Present address. Ah, okay. Okay, we already have this thing here already. And nobody told me. Yeah, you can only have one identity on a table. So to start with, what's this doing here? Identity shouldn't be for foreign key because foreign key is bringing in data from primary key. So identity shouldn't even be there in the first place. Let's see if it has created any tables there. No. Okay, let's try to run it again. Good. So we have all our tables created. Let's refresh and we're done. Now, there is more. It says, after you have successfully created tables, run the attached script to insert data into your tables. So there is a script that we distributed. You were meant to run it. Where is the script? Insert data. This is the script. So let's just run it. Okay, so okay. Actually, I think this is the old version of the script. Let me get the latest one because some things were changed. Hang on a minute. And again, mind you, this assignment was actually something to test you. It was actually designed to make you run into errors like this so that you can find a way to deal with the errors, because part of the learning for SQL is dealing with errors. The more errors you come by, the better you become at SQL. Trust me. If you see errors like this, don't be scared. Don't be sad. It is good, because have a look at this. For example, it says explicit value must be specified for identity column in table person address, either when identity insert is set to on. This error message alone will teach you two things, two important things. And what are those things? Number one thing is this. It says explicit value must be specified for identity column. Any explicit value must be specified for identity column in table, either when identity insert is set. So what that means is, if you have a table that has identity column, meaning automatically is incrementing, if you want to insert data into it, you don't have to specify a value. Just leave the database engine to do it itself, to specify value for it. But if you must specify a value, then there's a command called identity insert. And then that is when you can now override the database engine's automatic insertion. So when you turn it on and off, you can do things like that. But I already wrote the statement to do this for us anyway. So I don't expect us to start troubleshooting this here. But, just for you to know that traps like that already on there. Okay, let's delete this and try to run it again. Right. Let's create the database again. Ooh. Oh, it was running it in temp database 3x.2. Okay, let's just deal with this once and for all. So what's the table? Person address. Where is person address? Let me teach you something again. If you have an issue like this and you have a chunk of query like that, just copy this like this, type Control F to quickly look for it. Find next. Okay, so this is it. So we have set identity insert on right here, on and off. Person address. Okay. When the replication user is setting into not for. Oh, this is interesting. It's a different message. Okay. Oh, or when. Okay. Actually, let's have a look at what person address. Data 1000 rows. Okay, we don't have data for that. So we already have data for this. So we can isolate the problem. So we have for this, we have data for that. Okay, so this is the only table with a problem. How about products? We have some data. We just need some data to work with, really. Okay, we have some data here as well. So that solves our problem. So what we can do in this case is we can see that the problem is person underscore address, right? So let's just take it off. Let's just take it away. Put it in a new query. Okay. And we're trying to insert data into it. So let's run it again in isolation and get the error message out. So it says insert blah blah blah. Okay, let's take this away first. Let's see. Okay, so the problem was actually the set identity insert. So that's sorted. So now we can have, okay, so these are troubleshooting skills. When you have problems, you want to, number one, isolate the problem. The ones that are fine, get them away from the ones that are not fine, and then focus on the ones that are not fine and see how best you can deal with it. Okay, so we have this sorted out. We're fine. We can proceed. No problem. I'm looking for the requirement. Okay, there. Now it says write select statement to retrieve the following data. Okay. Now this is where our agenda comes to play. We had an agenda here to deal with select statement and the asterisk symbol. Okay. It says write select statement to retrieve the following data. Let me just copy this away and open a new query. Remember, I taught us sometimes ago how to comment something else. For example, if I wrote blah, 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 and I don't want the database engine to consider this when it's executing, I will just do this, right? Okay, now there's another one. Instead of me to do this one by one by doing that and that And that, imagine if I had thousands of lines like that. Instead of me going that, I can just do them in a block and just type / and star, and then star and / and then in block it comments out everything. Right, okay, so write select statement to retrieve the following data. What data? Return all data from sales territory table. That's simple. All you need to do is just do this. Select asterisk from, and then you put the name of the table. And then if you execute that, it brings out all the data. So what asterisk means is everything. So we're going gradually into select statement, how to use the select statement. Anything select is typically used to return data, to bring back data. So if I wanted, let's say, okay, what columns do we have on this table? If I wanted just territory ID and sales YTD, sales YTD means sales year till date. I could just say select territory ID, comma, sales year to date. And that's it from the name of the table. And if I click execute, it's just going to return back those two data, those two columns for me. If I wanted to increase the number of columns I want back, I could just say, okay, add one more column. So it's interesting that we have something called IntelliSense. And what IntelliSense does is, this is the spelling of IntelliSense. I believe I'm right. And what it does is, if you're trying to do something, the Management Studio will try to guess what you're trying to bring back. So if I type in sales, you see, it's suggesting to me. So that's IntelliSense. So sales last year is what I want. And then it's brought back that. So I just wanted you to see this in action, asterisk. So instead of typing all the columns one by one, I could just say asterisk, and then it brings back everything. That's how to return data. So if I wanted to do the same thing for another table, I could just say select asterisk from, let's say, product. And if I highlight this and execute, it will bring back data. And don't forget, Management Studio the database engine will try to run everything in this query analyzer window if I don't highlight what I want. So if I don't highlight anything and I just click execute, it will return data from this table and that table as well. Okay. All right. So that's that. Now we want to introduce something more from this requirement. It says data from sales territory table where sales year today is more than 5,000. So let me put the requirement. Oh, it's there already. Okay, yeah. Data from sales territory table where sales year today is more than 5,000. Okay. Let me test you. Can anyone suggest to me? I don't want Femi or Ahmed to say anything here because I believe they've gone through this before. But anyone else, can you tell me how I can retrieve this data from the database? I want something from this sales territory table, right? And this column, sales year to date, something that is more than 5,000. More than 5,000. Actually, everything here is more than 5,000. Let's change the requirement here. Let's say less than 5,000. Less than. Can anybody attempt to do this? Less than, let's say, less than 50,000. Yeah, something less than 50,000. Yeah. Okay. All right. Okay. Someone says he has a question. Oh, okay. All right. Question. Okay. Somebody has reason there. Sorry, because I've been looking at my screen since I'm just seeing this now. All right. Femi has a question. All right. While you're still thinking about that, I'm going to unmute you now, Femi, so you can ask a question. All right. Femi, go ahead.
Okay, my question is for foreign keys.
Mm-hmm.
If for foreign keys, can a foreign key colon uh, be empty? Let's say be null or be empty.
Yes. 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 It all depends on how the business wants that data to be bought. Yes, it is. It's possible for foreign key column to be empty. It is possible. In some cases, you can find that. Don't be surprised when you see something like that.
Okay.
Yeah. Yeah.
Yeah.
Because
Yeah.
if you think about it, if you think about it, I'm trying to think in what sort of situation you can see that happen. Well, I've seen it before. That's why I can emphatically say yes, because I've seen it in a production database like that. And I also asked the question then that, okay, so why is this possible like that? But I've seen it. So it is possible. Yeah.
Okay. Okay.
All right. Okay. Ahmed, I'm going to unmute you so you can ask your question as well. Go ahead. Ahmed, are you there? Okay. He's asking a question. Let me just copy the question and paste it in here for everyone to see. Is null and empty the same in SQL Server? They're not the same. They're not. You can have, okay, for example, we have null here, as you can see on the screen. We have null here. And let's try to insert data, and this will demonstrate your question now. Let's try to insert data into this table. So insert into this table. Okay. It's quite a long, but let's try to do it sharply. North, east, country, region, because the way I'm inserting is this. Let me just carry everyone along with this. When you're trying to insert, the syntax is insert into the name of the table, and then you have to pick on the columns that you want to insert into one after the other. So territory ID, we know it is automatically incremented, so we don't need to specify and say territory ID, no. So we can just say, to make it clear, let's specify the columns that we want to insert into. So name, this is name column. So name, we have Northeast. Okay, the next one is country region. Country region code. And what's the value? The value for northeast is NE, right? Okay. Okay. I know you'll be looking at this and say, oh, but that's NW. Don't worry. It's just dummy data. You know, that's what they call pseudo data. So it doesn't matter. All right. So the next one is sales YTD. sales YTD. Okay, sales YTD, and the value is what? Let's just give it some value, 4,000. The next one is sales last year. That's right, sales last year. Sales last year with a comma. Okay, and let's say 6, 7, comma, and we have created date. Let's say created date. Now let's do this. Let's do this. I will just put space, and that's it. Now don't forget, modified date has default, so automatically it's just going to put the current system date and time there. Oops, sorry, this was meant to be for here. So this is meant to be says last year created underscore dates, and that's it. So we don't intend to insert anything for modified date, because we know it will automatically. Okay, let's try this in this database and execute. Oh, okay, there's something missing here. Values. Okay, so this is the syntax. If you want to insert into table name, specify your columns, and then you say values, and then specify your values. It's as simple as that. Now look at this. Actually, this is not really a good example, because it's giving us a bad data. Let's actually use country region for it, because I want to demonstrate null and empty. This one we can say 2016 space what's today's date? 06. Yeah, okay. Let's insert this again. Okay, now let's select. You can see, so this is what I'm trying to demonstrate. This is empty, this is null. There's difference between the two. Okay, so you can see this is empty. It's just white spaces. It's nothing. And null is a value in itself. If you think about it, null is a value. Null means a data should be here, but at this point in time, I don't know what the data is. This is a value, and it's telling you the value is white spaces. Does that make sense? So there's difference between the two. And this has nothing to do with SQL Server. It's the same way in any good RDBMS out there, Oracle, MySQL, anywhere. This is how you will find it. So, I like the fact that we digressed a little bit, because we've learned something here. But let's go back to what we were trying to do before. All right, so what was the requirement? The requirement was, it says data from sales table where is more than 5. So we said we wanted less than some figure. Do we have anybody? No, nobody. Okay, let's just go ahead. All right. Now, if I now want to start filtering data to say, okay, I want this kind of data, I don't want that kind of data, that's where something called the where clause comes to play. Where. Okay, so what am I looking for? I'm looking for a data from this table, this column. Okay, just pick the column where sales year to date is what? Is less. Remember, less than, greater than, those symbols. This symbol means less than. It's less than, what's the value? Less than 50,000. Less than this value. If I execute this, it's about just a few, just to the ones that we actually just put there, because the sales year to date is less than 50,000. If I wanted it for sales last year, all I need to do is just change it to sales last year. So it will return data based on the values on this column and the requirement or the predicate, which is saying less than so. In this case, we have just one from Australia. Sales last year is 1,657, right? So that's how to do this. So you're going to have more assignments on this week that we're entering. So this is to prepare you for next coming week. And the last one says name of all the customers in the company that are in Northwest Territory only. Now this is also introducing something else to you, which is joins, and I'm still going to give you materials dedicated to joins, but I want to use this to gradually introduce you to the concept of joins. And joins is just basically joining two tables together. And if you remember from our first session that our DBMS is you make sense out of relational database management system when you join tables together. So things will begin to make sense to you now by the time you start joining tables together. Now, it says name of all customers. Oh, we have customers table. This is the trend of thought. This is how you start thinking about it. Oh, okay, we have customers table. Okay, let me see. What do we have in customers table? Let's see. What do we have in there? So start from customers. Oh, it's customer, not customers. Okay. Select everything from customer. Okay. So it says customer ID, person, territory, but nothing here is showing me name. And the requirement says name of all customers in the company. Before I even look at this at all, I want to fix this first. That's how to do it. You know that there are two problems you have to face here. Name of all customers in the company that are in Northwest Territory only. So this is another trouble you have to deal with. But first and foremost, you need to deal with this first. The one you're looking at first, name of all customers in the company. I need to get names of all customers in the company. Okay, I've come to customers table. I can't find any name. But what can I find? I can find IDs. Person ID. Okay, person ID suggests to me that this is a foreign key and it relates to another table. And what's that table? That table is person, where the primary key exists. Okay, so on this table, there's a foreign key. So what I will be inclined to do is, okay, let me have a look at what's in the person table and put both of them side by side. I'll just select both of them, put them side by side. Okay, we're getting somewhere. So we have person ID here. We also have person ID here. And on this person table, we have names. And our requirement is asking us for names. Okay, so that's to tell me the names that I'm looking for is actually on this table. But you have to be careful, because if you then say, okay, fine, let me just bring names from here, you have to be careful, because the names that are contained on this table may not be customers. We may have employees here. We may have students, depending on what the company is about. If it's a school, it may be name of their HR, their customers, their employees, everybody. So, but we have a table dedicated to customers. Similarly, we can have another table dedicated to employees. But in this case, we're concerned about the customers. So what we need to do then is find a way to join these tables together based on an ID column. And what's that ID column? That ID column is the person ID. Okay, because it is common to both of them. So what I would do then is there's something called join. Now, this is, let me warn you, this is going to be quite confusing. I promise you, I'm going to send you a separate material on joins. But for now, don't try to cram anything. Just see this in action so that by the time you start watching the materials on join, it will make more sense to you. So just see what I'm just going to do now. Okay, I want to join these two tables together. And I'll say select start from customer, join with what table? Okay, select star from customer, join person. Now I need to join them based on something. And what's that thing? Person ID column. Okay. On. Okay. On what? On customer dot person ID. So what I've done is I've said customer dot person ID, which is this table is person ID equals to this table, this other table, which is person dot person ID. That's just what we're doing. And what am I looking for? I'm looking for name. Okay. Now, SQL Server is going to be confused because it's going to say, okay, you're looking for something, but you're joining two tables together. Tell me, this thing you're looking for, from which table should I extract it? And then I have to tell it, okay, name is on person table. So I'll just say person dot name. Actually, it's not even name, it's first name dot first name. And if I execute this, person ID, it's person underscore ID. I believe this should work now. Oh, okay, let's select star from customer. Let's see what the name of the column is. Okay, it's not underscore. Okay. So you see, so what we've done here is join two tables together, and this will confirm to us that these names that we have retrieved are actually customers, right? So we've solved the first part of the equation, which is name of all customers in the company. Now the second one is saying that are in Northwest Territory only. Okay, so that means we have to deal with another table that is holding Northwest data. And what's that table? Our sales territory table. Let's see. Right, okay. Now we have something to deal with here again. We have sales territory table. Right. but there is nothing on this table that is talking about customers. So we then need to go back to our customer table and say, okay, let's see if customer has something talking about territory. Territory, sales territory. Okay. So if you look at the customer table, it has territory ID. So that's good enough for us. So we can join customer table and territory ID together based on what column? Territory ID column. These two columns. So to do that, we just need to proceed in this same query and say again, join. What are we joining now? We're joining the third table, which is sales territory table. Okay. On what? Sales territory ID. Remember. So say customer dot territory ID equals the other one, which is sales territory dot territory ID. Let's try to run this. Dot customer join sales territory. We're having a syntax error here. Person ID join sales territory. That's the name of the table. Oh, okay, I've seen it. On these two columns. So you see, so we have that, but it says that are in Northwest only. Then we have to introduce this where clause again. Remember, where, what's the name of the column that's holding regions? Where is it? Name. Okay. Where sales territory, because you have to specify the name of the table. So because about now we're joining three tables together. So we need to be able to tell it which of the tables we want to take the column from. Okay. Equals what? Northwest. Equals Northwest. And remember, anything that has to do with non-digits, we have to put them in single quotes like this. And it doesn't bring any data. Reason because we don't have any customer in Northwest. That's just the reason why it hasn't brought any data back. But let's see if we have some in other regions. Let's see, we have some customers in Northeast. Oh, we do. We have Allen and Alakija. Let's see if we have some other in other regions, Southeast. We have just one, David. So this is an example of the building blocks to retrieving data and working with data. But don't fret if you don't understand this in detail right now. I can understand this is really daunting and confusing, especially when you're newly introduced to it. Like I said, I'm going to send you special materials that will give you detailed understanding on these topics, and it will help you to understand more. Now, finally, before we go, there's something I actually planned that we will deal with today. Time has been fast spent, but I hope we will. I'm not sure. Should we leave this to next week, or should we spend another 30 minutes? It's up to you guys, because we haven't gone on break and we've been on this for 2 hours. So please, I need you to say something, guys. Do you want me to quickly go into that? Because I've actually loaded quite a number of things, to you today already. So I don't want to give you too much to do. So I need you to type in so we know where we are at. Come on, guys. Should we stay or should we just go and see you again next week? Nobody's talking. Nobody's saying anything. Next week, okay. Shala says to leave to next week. Lolade says I'm okay with others. Ahmed says let's just finish up. Okay. Okay. Bimshala says next week. Okay. All right. So guys are tired. All right. Okay. I'll leave it to next week, and I'll leave you to digest this. All right. I'll leave you guys to digest this. It's been loaded already, and next week we'll look into that in more detail, and during the week I'll give you more materials to study and more assignments to do to get your hands a lot more detail on this thing. Thank you very much. I hope this has been very informative for you. I hope you are learning new things every day. Do we have any questions? Anybody with questions? Femi is raising up his hand. Femi, go ahead.
All right, my question is back to the foreign key thing, and it came to my head whilst you were doing the join.
Yeah.
Imagine you want to join a table, and you are joining based on the foreign key relationship.
Yes.
And you have left a particular row without a particular row without a foreign key value.
Yeah.
Right?
Yeah.
Now, if you go ahead with that join, where you need to join details, you need that details from that particular table. If you go ahead with that join, will that give you, will it work?
Yeah, it will work, right? Because don't forget, the what's it called? The value that you're joining on, right? What is going to do is it's just, let me run this query, for example. Now let's say we're joining on customer ID, and now let's look at something that has both columns, customer and person. From person, okay. All right, so let's say we're joining on person ID and person ID. Now this is a foreign key here, right? Now what you're saying is, check, is this one, does it exist here? One, okay, if it exists, pull back the data. Two, does it exist here? Yes, it exists, pull back the data. Imagine this is null, right? Null is here, it will check, is null here, it doesn't exist, it will just keep it, because there is, nothing is matching there. All right, so it will work. Now if you now put an additional where clause and said where person ID is null, then it can give you some data. Does that make sense? So that's why sometimes in this case you can use where clause to pull back certain data back, but even though your foreign key has some null values, it will still work. because it's just going one after the other to check, it's looking up, it's performing lookup, from both tables. That's what's going on. Does that answer your question?
Okay, yeah.
Okay. All right. Shola is raising up his hand. Shola, go ahead. Okay, he's not saying anything, but he was raising up his hand. All right. Okay, so I'm gonna leave everybody to.
Hello, can you hear me?
Okay, yeah, I can hear you now.
Yeah. Sorry, I just would like to know and to be sure I'm not mixing things up. Based on the question you asked earlier, was concerning trying to remember the question. Okay, retrieving using select statement to retrieve data from the tables.
Yes.
Now, I suggested a question, an answer. I said we use order by ascending order. Is it the same thing with the thing we just used, or is it different? I'm just
We haven't
a bit
introduced
confused.
order by at all.
Right. Okay, so it's just the where clause that we need to use in that situation.
Where clause is used to filter data. Order by is used to sort your data. So you may want to sort by ascending or descending. Where,
Okay, filter and sort. Okay.
yes, yeah, two different things. To filter and to sort data, they're two different things.
Okay. Okay. Thank you.
All right. Okay. All right. So I believe that's all for today. Thank you very much for your time. It's been a pleasure to be your instructor for today, and we'll see you next week. Have a nice evening, everyone. Bye-bye.